For week 2, and just as a reminder, the reading assignments are chapters 3, 3A, and 4 from the course text and the corresponding chapter treatments presented by the Notes to Syllabus Supplement. You don't have to hand in the following an assignment, but you are expected to work through the chapters 3 and 4 end of chapter technical questions and even numbered application questions to ensure thorough preparation for the examinations that will be administered. As you know, the text provides solutions to the previously identified even-numbered questions, so you can readily check to see that you are on the right track when addressing these questions. As part of the weekly assignment, remember that you should select and be prepared to discuss a current business or economic event reported or analyzed by a prominent national publication that reflects a relationship presented by the reading assignment. Based on the readings assigned for week 2, we first will consider in greater detail a number of relationships associated with demand curves. From week 1, we know that demand curves are downward sloping in the general case, and that this negative slope indicates an inverse relationship between changes in quantity that occur as a consequence of changes in price. We now want to identify the degree of sensitivity that quantity demanded will have as a consequence of a price change. In the general case, this degree of sensitivity will vary depending upon the segment of the demand curve which is under consideration. Formally speaking, price elasticity of demand measures the percentage change in quantity demanded as a consequence of an inversely related percentage change in price. Why is this a critical measure? As an example, suppose a firm has assessed that the demand for a given product it produces is price elastic. Further, suppose this firm is contemplating lowering the price of this product. What would be the outcome? When demand is price elastic, the percentage increase in quantity demanded will be greater than the percentage reduction in price. Since total revenues equal quantity sold multiplied by the price at which this quantity is sold, total revenues will rise, a result that may seem counterintuitive at first inspection. At the lower price, a greater quantity will be sold, hence total costs will rise. However, as long as the increase in total costs is less than the increase in total revenues, profits will rise. I think it is fair to state that, in the area of managerial decision-making, possessing a firm grasp on the preceding relationship is not a bad idea. There are a number of other elasticity relationships that are no less important. As an example, is a given product perceived by consumers to be a necessity or luxury? The income elasticity of demand measure informs us as to the category in which such a product falls. It is also worth exploring the fundamental microeconomic basis upon which consumer demand arises. We assume, in microeconomics, that consumers fundamentally are motivated to maximize the utility, that is, the satisfaction, they derive from the act of consumption. Keep in mind that, as the term is used in economics, consumption is a broad classification. In other words, consumption is not restricted to the consumption of goods and services. As an example, most people value and thus consume time devoted to leisure. Of course, there is a catch associated with the motivation to maximize utility. Consumers are constrained from achieving ever greater levels of utility by the reality posed by their income and wealth levels. The graphical analysis presented by the course text demonstrates how consumer demand curves are derived based on a model of consumer utility maximization subject to the constraint posed by income. Familiarity with the implications of this model leads to a number of insights. For example, consumer indifference curves embody consumer preferences. Influencing these preferences, say through the implementation of a successful advertising campaign, exerts influence on demand curves. Let us now consider the thrust of the material, namely regression analysis, presented by Chapter 4 of our course text. Here's the good news. The approach we're taking is an applied approach. In other words, what we're not going to do is derive an algebraic proof of a regression equation. Instead, we're going to use MS Excel to implement this equation to provide us with results that can be used to characterize a variety of important real-world relationships. Here's an example. Suppose you are a mortgage lender. It's an empirically supportable fact that mortgage originations are influenced by changes in mortgage interest rates. In turn, mortgage interest rates are a significant input into the determination of the effective monthly price of purchasing and owning a new home. In other words, changes in mortgage interest rates exert influence on changes in the quantity of mortgages demanded. The law of demand in action. If we want to quantify the degree to which changes in mortgage interest rates exert influence on changes in the quantity of mortgages demanded, we can compile a time series of mortgage interest rate and mortgage origination data. If we construct a graph of this relationship and fit a line to the points plotted, this line will inform us quantitatively what the empirical relationship has been over a given time frame. This linear construct also will provide us with a basis for predicting what the future changes in mortgage originations will be in relation to future changes in mortgage interest rates. The list of applications for applying regression analysis is rather lengthy, and depending upon the professional path you're on, it likely is the case that you will never be called on to perform such an analysis. But you never know. Still, the importance of the insight provided by such an analytical skill set cannot be underestimated with respect to its relevance to a variety of business decisions. Not to mention the reaction that will be forthcoming if you ever have the opportunity to raise the subject at some future business meeting. Inescapably, we are always competing with our professional peers, and this being the case, it's never a bad idea to possess a competitive advantage. Typically, most graduates of an MBA program will have been introduced to regression analysis, but they can't actually apply it or meaningfully discuss its implications. That will not be the case for us.